Hi there! Welcome to Explain This, a podcast where we try to explain complex things in simpler ways for people of all ages. I'm your host Jin Kim, and today we'll talk about a sneaky, weird, barely living organism, the bacteriophage. Let's get started. We often fear terribly large, scary creatures like lions, tigers, sharks, and giant lizards. But history has shown us that the most deadly things in the world are often things that are invisible to our naked eyes. Bacterial infections have terrorized human beings since the dawn of time. Pneumonias can steal our breath away, meningococcus can kill a healthy young person in a matter of 24 hours, and don't even get me started on wound infections and dysentery being the leading cause of death during wars, more than any weapons humans have ever invented. But turns out, even these teeny tiny infective single-celled organisms, they can get a taste of their own medicine too, because they can be infected by something even smaller, bacteriophages. Now before we get into what bacteriophages are, let's start by explaining them to you as if you're 5 years old. Imagine that you're diligently making cookies. Now because you're not a pro baker, or your mum, you're following a recipe to the letter to make sure you make the moistest, chewiest, tastiest cookies. But then, a mischievous magic cookie fairy shows up to mess with your cookies. Now this is a sneaky fairy, so you don't even see them coming. While you're not looking, they take your recipe book, add some lines in there, and they change the recipe. Now because you fully trust your handy dandy recipe, you don't even double check to see that there are any errors in it, and notice that the recipe is looking a bit funny now. When the cookies come out of the oven, surprise! Turns out you didn't make delicious cookies, but you made even more magical cookie fairies instead. And don't ask me what the recipe for magical cookie fairies are. Only the Fays know that. Anyway, these magical cookie fairies fly off to change other unsuspecting children's cookie recipes, making even more fairies. And that's the story of how the cookie fairies took over the world. Welcome back. Damn, I feel like baking cookies now. Alright, so what is a bacteriophage and what do cookies have to do with them? If you've studied your Greek, then you'll know that phage means to devour. It also sounds badass. So bacteriophages literally mean devourers of bacteria. These are a type of virus that only infect bacteria, not like the flu virus or herpes that affect animal cells. Now I find bacteriophages fascinating because I love the thought that even a single-celled, infective organism can be infected by an even smaller thing. It's like the scene in Star Wars The Phantom Menace where Qui-Gon Jinn says, "There's always a bigger fish." Well, turns out there's always a tinier infection, so it goes both ways. Anyway, I think we should start by explaining how viruses work first, before we talk about bacteria infecting viruses. Cells are basically tiny biological factories. It contains DNA, which is the instruction manual, and tiny protein machines called organelles that read the instruction manual to produce the parts. We won't go too much into the details of how DNA is transcripted and translated, because that's a topic for another day. Essentially, the cell reads the DNA, makes a photocopy of a part of it, which we call RNA, and then gives it to the ribosomes, which are tiny machines that make proteins. Ribosomes look at the RNA instructions and they follow it exactly. And this makes a very specific protein that the cell can use, whether it be spare parts to repair itself, produce things to pump out of the cell like antibodies, etc. It's basically how a cell functions and how life happens. Now, viruses are weird. Scientists are still arguing, more than 100 years after their discovery, whether viruses are alive or not. This is because viruses are literally just genetic material wrapped up in a protein case. They can't create energy, feed, breathe, metabolize, or even reproduce without another cell. But it's damn good at making other things make more of itself. The way viruses work is that they infiltrate a cell, using their protein shell to attach and merge into another host cell. Once inside, the virus releases its DNA or RNA package. Now remember when I told you that cells have ribosomes that can read genetic instruction manuals and build proteins? Well, turns out they don't actually care where the instruction came from as long as they can read it. Probably because they're underpaid and unappreciated, to be honest. So the host cell starts diligently pumping out proteins as per the virus's instructions. What do you think these sneaky instructions code for? That's right, more viruses. Viruses hijack a cell's protein-making functions to create more copies of themselves, until the cell's just filled up with new viruses. Then, the virus triggers the cell to burst open, flooding nearby cells with fresh viruses to infect and hijack. Now, bacteriophages aren't much different from other viruses. They use the same process to attach to bacteria, inject a piece of DNA or RNA into it, get the bacteria to build more virus particles using the instructions, until it fills up with viruses, then explodes, releasing a fresh batch of viruses. We call this the lytic process, where lysis means to cut or burst. There is one other way bacteriophages work, called the lysogenic cycle. Don't get too bogged down by the name, just have to know what it does. Now here, the viruses are extra sneaky. Instead of hijacking the bacteria and making it explode, making it unusable, the virus injects its DNA into the bacterium's own DNA. It essentially writes itself into the bacterial genome so that it becomes part of the bacteria genetic makeup. This means that every time the bacteria divides and multiplies, it passes on the viral DNA to the next generation. Eventually, when the time is right, the viral DNA activates itself, making the bacteria produce more viruses, and then boom, lysis. Cell explodes, lots of viruses. Virus 1, bacteria 0. Creepy as it sounds, it happens to us too. If you look at the human genome, that is the entire sequence of our DNA instruction book, about 8% of it comes from viruses. That's right, turns out you're 8% virus. Kind of. Alright, so now that we know what bacteriophages are and how they work, let's take a short break. Afterwards, we'll talk about why they are so cool and why they are relevant to modern medicine. Welcome back. So why are we getting all hyped up about a virus that infects bacteria? I mean, it doesn't even affect us, right? Do we just want some schadenfreude watching bacteria suffer death by infection like they do to us? Well, kind of. You see, when scientists discovered bacteriophages in the early 20th century, they realized quite quickly that they could be really useful, because they kill bacteria but not human cells. Remember, this is before sulfur drugs and penicillin, so doctors were frantically searching for a way to treat bacterial infections. Bacteriophages were a potentially awesome, badass answer. Like fighting fire with a smaller, deadlier fire that doesn't burn us. But alas, the initial trials of phage therapy weren't that successful, and antibiotics swooped in and filled that niche much better. They were used with limited success in Soviet Russia, but by that point we had hundreds of much more effective antibiotics that could do a better job. However, that wouldn't be the end for phage therapy. You may have heard of something called multi-drug resistant bacteria, or quote-unquote superbugs. Much catchier name, kind of inaccurate. During the past century, we have been engaged in an epic arms race against bacteria. While we've been developing more potent and safer antibiotics, bacteria have been figuring ways to neutralize or evade antibiotics, making them resistant to our treatments. It's gotten so bad that we're seeing germs that are resistant to pretty much anything we have to throw at them. Even the nuclear bomb of antibiotics don't work on some of these bugs, other than bleach. But no, putting bleach in your bloodstream doesn't work. Stop trying to make it a thing. It's like burning the haystack to find a needle. So now, we live in the scary age where bacteria might be winning the arms race. Because it takes decades and billions of dollars for us to develop new drugs, but bacteria can mutate just like that. Enter phage therapy. In recent times, some clever scientists have figured out that although bacteria are getting more resistant to antibiotics, they haven't built up the same kind of resistance to bacteriophages, because it's a completely different mechanism of action. If anything, because they're using up precious resources on anti-antibiotic technology, they're more vulnerable to phages. So if we can harness the power of bacteriophages, we might be able to turn the table and completely crush bacterial infections, see it driven before us, and hear the lamentation of the other germs. It's an exciting new field of drug development, because it treats nasty resistant bacterial infections on a completely new axis. It's like pulling a gun out during a knife fight. That's how cool it is. So watch this space. In 10-20 years' time, instead of a course of antibiotics, you might be treated with a course of viruses instead. It's interesting because with bacteriophages being so hot right now, researchers are finding out more and more about these curious viruses and how they may be helpful. Recently, a friend of mine taught me about how they think bacteriophages may be the reason why fecal transplants work too. Wait, fecal transplant? Like putting someone's poo in someone else? Why? Yeah, so medicine doesn't really judge or kink shame. We use whatever works. Fecal transplant is a novel technique where we take poo from a healthy person, put it in a capsule, then administer it to a patient with a gut illness, like a Clostridium difficile infection, which causes profuse diarrhea and can actually make you quite sick and kill you. No, seriously, I'm not making this up. You see, C. diff is a bacterial infection that occurs because your normal gut bacteria have been wiped out as collateral damage by antibiotics, or after a really bad diarrheal illness. So all the good bacteria are gone, and the bad bacteria decide, ooh, there's some free real estate here, and they just move in and take over. Scientists figured out that instead of giving even more antibiotics to kill the C. difficile bacteria, we can instead reintroduce a healthy population of gut bacteria, or biome, to the patient gut. Then the good bacteria fight off the bad bacteria, and order is restored. And you stop having explosive diarrhea. Treating poo with poo, as you might say. Yeah, modern medicine is awesome. Anyway, turns out there's more and more evidence that shows that it's not healthy bacteria that we're transplanting that's helping the patient, but the bacteriophages that infect these bacteria. So what happens is you transplant bacteria infected by bacteriophages into the patient's gut, then the bacteriophages go on to infect the C. difficile bacteria, killing them off, like an elite Navy SEAL team working in the shadows. With more research, we might be able to isolate these phages and administer it as an injection into the bloodstream, instead of finding poop from your family member, putting it in a pill, and making you swallow literal crap. How flippin' cool is that? Alright, before we go, one more application of bacteriophages. Remember how I told you that most phages reproduce with either the lytic cycle, where the bacteria fills itself up with new virus until it explodes, or the lysogenic cycle, where the virus injects DNA into the bacteria's genome so that it gets copied over many generations? Well, we've learned to hijack the latter process to do the same things viruses do. We can tinker with bacteriophages and their DNA to choose what kind of DNA it inserts into bacteria. This means that we can make a phage that injects a specific piece of DNA into a bacteria, telling it to produce any kind of protein we want. And this is particularly useful if we want antibodies to use as a medication, because that's a protein, and instead of creating fancy machines to print them, we can use sophisticated, pre-made biological factories that evolved to make these kind of proteins in the first place. This is called phage display, and it's like turning a bacteria into a 3D printer for drugs. It also feels like karmic justice, where we're infecting bacteria to produce medicine so we can treat other illnesses. Suck on that, bacteria. Now, the principles of how viruses and phage display works is quite relevant in recent times, because humanity has recently made a huge scientific breakthrough, the mRNA vaccine. We'll do an episode in the near future about how vaccines work in general to prevent viral infections, but essentially the normal way is that you inject an inactivated or harmless piece of a virus into the body so that the immune system learns how to fight against it without ever being properly infected by the virus. It's like putting up a photo of your enemy on a punching bag and fighting against that punching bag so you know exactly what to do when the day comes to duel with that person. But with this new mRNA vaccine that has come into the spotlight because of the COVID-19 pandemic, we use a very cool, different way to immunize people. With mRNA vaccines, instead of injecting inactivated viruses, you inject special nanoparticle packets that have pieces of RNA inside. These packets act much like a virus, infiltrating your cells, planting their RNA inside the cell, and tricking the cell into making whatever protein the RNA tells it to, much like a viral infection. In this case, the RNA encodes a piece of the virus. For example, the COVID-19 vaccine teaches cells to produce a spike protein on the outside of SARS-2 coronavirus that causes COVID-19. The protein itself is harmless by itself. It's just like the t-shirt that the virus wears, not the deadly knife that it uses. The cells will produce these spike proteins, then show it to the immune system. The immune system will be all, whoa, where did you find this? This stuff is bad news. It then gets all riled up, raises an army, and trains it to kill that protein on site. So when a sneaky coronavirus enters your body, your immune system is prepared. They go, aha, gotcha sucker, and kills it before it can cause COVID in you. I find it fascinating that we're essentially using the same tactic viruses use to fight other viruses. That's the awesome thing about science. We learn and discover new things, then find creative ways to apply it to benefit humankind. Well, that's all she wrote for this week. What did we learn today? We learned that viruses are just pieces of genetic material wrapped in protein, but they can hijack other cells to copy themselves, until they burst out and infect more cells. We learned that bacteriophages are a type of virus that only infects bacteria. We learned that we can use phages to kill hard-to-treat bacterial infections, or to turn bacteria into mini living drug factories. Lastly, we learned that modern medicine is weird and wonderful, with things like poop transplants and vaccines that trick our body into producing virus bits. Well, that's it for today. Thank you for listening to Explain This. Hope you've learned something interesting and maybe even useful today. We'll see you next time. Bye for now. Explain This was written and hosted by me, Jin Kim. If you'd like to suggest a topic or just send a lovely message, you can email me at explainthiscast@gmail.com or follow me on Facebook or Twitter.